So I've been working on smoothly interpolating between two skeletons in Godot 4 using the Make Human plugin for Blender 3D models. So as you can see, I'm able to transform between the base skeleton and the shape keys. And when you change the slider, the animations still work. So the fingers and the neck are still in the right position. There's no deforming like we had before. And as you can see, both of them work with the animation, which is good. So the issue is I haven't figured out how to merge the blend keys. So if you have more than one shape key and the basis, or two shape keys that you want to transition between, this doesn't work. One of these has to be set to 0 basically. So I haven't figured out yet how to merge them, but this also involves manually exporting each shape key skeleton from Blender. So I would like to calculate it programmatically. If you go to the Make Human for Blender plugin folder in the zip, you can go to Data Rigs Standard, and there's a rig.mixamo JSON file here. So this does have the default position of the bones and a way to calculate between the vertexes to change the position. Now some of these have a different format. Instead of mean, it's using cube. So I'm not sure exactly how all that works. I have tried a little bit and didn't have much success. So at some point I will probably build the skeleton from this file. But currently I just wanted to get the skeleton and mesh to match up with the animations. So I'll go ahead and show you how I got this working, but I also have a link to the project in the description so you can download the source code if you would rather do that. So first I wanted to talk about the Make Human base mesh. I'm using Blender version 3.64. So I don't know if this will work in version 4. I saw they released an alpha recently. I have the Make Human plugin for Blender 2 installed, MPFB2, and the base system assets. So I'll make a new human from scratch, and you can change the phenotype if you want. I'll just create the human. And then under model phenotype, you can change the gender. So I'll set the muscle and weight up, and you can change all of the other features as well. So Godot can't see the blend shapes if you have the hide helpers modifier enabled, so I'll delete that, and now it adds the dress and hair. Then under operations, base mesh, you can delete the helper geometry. So now the shape keys are available, but the helper geometry is gone. Now you can't apply the rig or clothing once you've deleted the helper geometry, so you'll want to do that last. So I'll go ahead and save this in a new Godot project. Once it's done importing into the Godot project, if you drag the blend file into a new scene, you can see that the model is a thin female or neutral. So obviously the model has changed significantly. So you can select the Make Local option, and then under the mesh are the blend shapes, and you can basically turn up the appropriate ones. So there's the male, and I don't know where the muscle is, but basically this is not ideal if you're trying to make custom characters, but for me it's good because I don't have to worry about resetting the base mesh shape keys, and the skeleton always is relative to the same base mesh no matter what size the skeleton is, which is good for reduces the complexity essentially. So with that in mind, I'll make a new human from scratch, and I'll set all of the shape keys to 0. So if you just disable them like this, it hides the property but also disables it in Godot. So I'll set them to 0. And now you can see that the model is the same as the one exported to Godot. So this is our basis shape. That's why it looks like that. And I'll go ahead and save this. Now I'll go to rigging and add the Mixamo rig, add standard to create the skeleton, and under operations you can export the Mixamo reduced doll for uploading to mixamo.com, and you can download animations from here. So I covered that in a previous video. I'll go ahead and do that. Once I have the animations imported from Mixamo, you can see they are attached to the skeleton. At least one of them is. So now with the mesh selected, under operations base mesh, delete the helpers, which also deletes the modifier. So the mesh is changed slightly, but that's okay because in Godot it'll be the basis. So now I'll save this as the basis skeleton.blend. Once it's done importing into Godot, I'll add the basis skeleton to the scene, to a new scene, and make the node local. So we have the human rig with the attached skeleton in the default position, and then the 2 reduced skeletons from Mixamo and the animation player, which affects the skeletons. So you'll need to retarget this animation to the main human rig, and I covered that in the previous video as well, so I'll put a link to that in the description, and I'll go ahead and move these around. Now that the model is linked to the animations, and I can change between them. So I'll reset the skeleton to the default pose. And now some of the shape keys don't affect the skeleton, so the animations will still more or less be fine. There may be some clipping, but I don't need to adjust it. However, some of the shape keys will change the character height or width, and in the default pose, you can see that it looks fine. All of the fingers and the neck are all proportionate, but as soon as you change the animation, you can see the fingers get deformed. So obviously we want the skeleton to be the same size as the model. So I'll need to export the shape key skeleton individually. So I'll open up the basis mesh in Blender that we made earlier. This has all of the shape keys set to 0, and the helper geometry hasn't been deleted yet. So I'll find the young African male slider and set that to 1. And then under rigging, add the Mixamo rig. Then with the model selected, I'll remove the helper geometry so the skeleton remains at the proper size, and I don't need to worry about the mesh. And then I'll save this as the shape key name. .blend, and import it back into Godot. And once the blend file is imported, you can add it to a new scene to see the skeleton has been adjusted. Make it local and turn the corresponding shape key up. So now you can see that the skeleton is within the mesh. So the issue is, if you copy the original mesh over to the new one, you can see that the shape is deformed and set to where the skeleton is by default. So it took me a while to figure out how to fix this, and if you go to the blend shapes and turn up that slider, it just makes it even worse. So I finally figured out, though, on the skeleton, if you just reset the skin variable, it puts it back down. So I don't exactly know what this does. There's not very much documentation about it. So if you reset that, and then now you can set the shape key, and as you can see, everything is fine. Now to transition between the two skeletons, I'll get rid of this scene and make a new skeleton library 3D node, which will extract the positions of the bones in the skeleton. And I'll add the basis skeleton, make it local, can delete the nodes, and I just need the actual skeleton, so I'll delete the mesh as well. Now I'll rename this to basis, and then I'll add the African male variant, reset the transform and make it local as well. Grab the skeleton and delete everything else. And we'll name this one after the shape key. Like so. So I'll attach a new script built in, and in the ready function I'll loop over the child skeletons, and then I need to loop over each bone in each skeleton. So get the bone ID in skeleton, get bone count, and then I'll make a new variable for the bone position equal to skeleton get bone rest. So this will be the relative position of the rest pose, and you need to pass the bone ID there, and I'll just print the bone position just to make sure it's working. So I'll run the scene, and you can see it printed out all of the variables, all the positions. So they have 4 elements, X, Y, Z, and O. This is a transform, so it has the position, rotation, and scale data, I believe. So I'll need to save this to a JSON first. I'll put it into a dictionary and then save it as a JSON file. So first, I'll make a new empty dictionary called data. Then when I loop over the skeleton nodes, I'll set data at skeleton.name equal to an empty array. This is the node name, which is basis or the shape key name. So then for each bone, once I get the bone position, I'll append that to the skeleton array. And now I want to save the data dictionary to a file. So I'll make a new file variable using file access.open, and I'll set the file name to res skeleton.json. This will save the file in the project, the local project file structure, instead of the user folder, which is somewhere else. and not visible from the editor. And then I'll set the mode to file access.write. And call file store line. Then use the JSON stringify function to turn the data dictionary into a JSON string. So that will save to the file. And then I'll call the save function at the end of ready. And now I'll run the current scene again. I spelled append wrong. And now it's created a skeleton JSON file with all of the bone placement data. So now in the main scene, I'll attach a new built-in script to the root node, and first I'll want to make a skeleton library variable of type dictionary. Then I'll make a new function to load the skeleton library, and I'll copy the function from ask.go.engine.org. So this is to read and parse a JSON file, and I'll fix the formatting. I don't want to print it, so set the file path to res_skeleton.json, and then get the file as a string and parse the string as JSON. And we'll set the skeleton library equal to the parsed value. And I'll call the load skeleton library function when the node is done loading on the ready. So load skeleton library. Now you can't actually see the skeleton in the game mode. As far as I could tell, I toggled all of the debug options. So I'll use the built-in editor tool annotation instead to change it in the editor. So at the top, just do @tool like that, and you'll have to reopen the node to trigger the ready function. So now if I close and reopen the main scene, you can see that it prints loading skeleton library in the output, which means that the ready function was triggered and load skeleton library was called. So now I'll add a export variable to update the skeleton of type boolean set to false. Then I'll add the set function override. So call the update skeleton function when the value is changed. And I'll add a new function to update the skeleton. And for now, I'll just print updating skeleton so I can make sure that it's working. So now when I select the node, if I click the update flag, it prints out updating skeleton, so that will work. So now I want to just set the skeleton size to the larger version. So in update skeleton, I'll make a variable called skeleton to point at the Skeleton3D to make it easier to reference. Then I need a variable for the target name, and I'll copy that from here. This will be the slider name as well. Then I'll get the target bones array from the skeleton library at the target name. And I'll loop over the bone IDs in target bones.size. Now I'll get the new transform variable equals target bones at bone ID, and I'll set the bone rest pose for each bone in the array at the bone ID and to the new X form. So this will just switch to the other skeleton, or it should, but it'll throw an error because the file is saving strings for the transforms instead of arrays because the JSON doesn't have handling for transforms and vectors. So I need to convert those into arrays in the save file. So I'll go ahead and make a new script for the utilities function extending resource. Set the class name to utils so I can reference it. And I'll use static functions so they're global. I can call them from anywhere and I don't have to make a new instance of the class. So I need to make functions to convert between the transform vector 3s and arrays. So transform 3D to array, this will take a transform 3D. And I'll make a vector 3 to array, which takes a vector of type vector 3. Then I need to convert back from the array to the transform. And from the array to the vector 3 as well. Like so. So first I'll convert from vector 3 to array. So I'll make an empty array and append the vectors x, y, and z variables in order. I could also use a dictionary for this, but it's more efficient to just use an array, so I'll return that. And then when I convert from the array back to the vector, I'll make a new variable equal to a new vector from the x, y, and z values. So I'll use the third constructor and pass the 0, 1, and 2 elements from the array, then return the vector. Then when I convert from transform 3D to array, I'll make a new empty array and append so the transform has a basis and an origin, so I'll get the basis dot x and convert this using the vector 3 to array. So it is a array as well. So I'll convert the basis y and z and add the origin vector last, then return the array and convert back from the array to the transform. I'll get the x value equals array to transform array at 0, get the y, z, and origin values as well. Then I'll make a new transform these should be array to vector 3. So now I can make a new transform from the x, y, z, and origin vectors. So I'll use the last constructor and return the transform. And I'll go ahead and copy the save and load functions to the utils instead. So make this a static function, and I'll take a string path with a data that will be an array or a dictionary, so I won't specify the type. Change the path variable and rename this to save JSON, since we're specifically using the JSON stringify function. And then I can call utils.saveJSON with the skeleton JSON path and the data dictionary. And I'll move the load JSON from the main class as well. This will just take a string path and I'll change that to a data variable and return the dictionary. Then in the main, I can set the skeleton library equal to the utils.loadJSON from the file path. So now in the skeleton library class, I'll make a new variable to convert the bone position transform into a JSON safe array. So I'll pass the bone position to the transform to array, and then I'll append the bone JSON to the data array instead. And now I'll go ahead and run the skeleton library scene to regenerate the skeleton.json file and reload. So now in the main scene, once I load the skeleton library, I'll need to convert the arrays to transforms so it can use the transform. So I'll loop over the skeleton names in the skeleton library, then loop over the bone IDs in skeleton library at skeleton named dot count. Size, and I'll set the skeleton library at skeleton name at bone ID equal to utils array to transform of itself. I'll save that, and I need to reload to update the skeleton library. And now when I try to update the skeleton, it no longer throws an error. Now the skeleton didn't update because I set the rest position. So if I go to the Skeleton3D and reset all bone poses, now the skeleton has grown larger. You can see it has deformed the 3D model though. So as I talked about earlier, if you go to the mesh skeleton and reset the skin, it puts it down to the basis transform, and if I find the correct slider, now the model matches with the skeleton properly, and I can play the animations, and as you can see, they might not be perfect, but they are definitely a lot better. You can see the fingers and shoulders still look pretty good. So to reset the mesh programmatically, at the end of update skeleton, I'll call skeleton dot reset bone poses. You could call this individually for each bone in the for loop, but it's probably best to call it afterwards. And I'll call the Skeleton3D human mesh and set the skin equal to null, which resets the skin value. And I also want to set the target back to the basis. So I'll set the target name as well. And now if I run the update, and save the script. So now if I run the update, you can see the skeleton has gone back to the normal and the mesh is not deformed, and if I turn the value back down to 0, you can see it lines up with the skeleton again, like so. So now I want to adjust the mesh programmatically, and I'm not sure how to connect to the individual shape key changed signals, but you'll need a separate GUI for the player to create their character anyway. They can't just use the editor here. So I'll go ahead and make a new export variable for the slider. This will be a range between 0 and 1, and I'll name the variable set it to a float, otherwise it'll just be 0 or 1, so we want decimals. Then I'll override the set function and go ahead and set the value of the variable. Then I'll make a new variable for the mesh, set it to mesh instance 3D, and hopefully it'll do the auto completion, and then we'll point it at the human mesh node. Now I'll get the shape key ID equals mesh find blend shape by name, from the shape key name. And then I can set the blend shape value using the shape ID and the slider value. So I won't update the skeleton yet, I'll just change this. So now you can see that it smoothly transforms between the basis mesh and the shape key. And I'll go ahead and make the human mesh semi-transparent. This will be in the surface material override on the mesh node. Add a new standard 3D material, and under the albedo, first you'll need to set the transparency to alpha, and then you can lower the transparency of the mesh so that it's easier to see the skeleton. So I'll just do that for demonstration. So now when I adjust the mesh, this is still selected. Now to make the skeleton slide with the mesh, in the shape key export variable, I'll go ahead and get rid of the boolean and make a new variable for the shape name, string, so I can pass that as a parameter to the update function. And I'll give this a target name and target value, parameters. This will be a float and a string. So I'll get rid of the local variable and call the update function from the shape key export variable. Pass the shape name and value. So now I'll make the basis bones array from the skeleton library at the basis index. And for bone ID in the array, I'll get the target transform equals target bones at bone ID, and the basis transform equals basis bones at bone ID. Then I'll set the new transform equal to the basis transform call the interpolate with function and pass the target transform with the target value. And then it'll set the bone rest pose. So I'll save that. And now when I change the slider, you can see that it changes the size of the skeleton as well. And you can see that the animations are still working. I'm not sure why it breaks the toes like that, but I've noticed this in the base model, like on the basis as well, and sometimes it doesn't do it. So as you can see, that's all pretty much working. So this is fine if you only want to interpolate between two base models. Like if you just have the age up transform on the skeleton and that's it, and all your models are the same otherwise, this will be fine. But of course, I'll want to combine multiple shape keys, and I believe that's an additive transform. So instead of an averaging, because adding multiple shape keys can increase the maximum size. So it might be just as simple as adding them all together and then applying the weight, but I'm not exactly sure. So that's why I'm looking into generating it from the actual points in the mesh. And that way I don't have to export all of the possible skeleton variations. So that would be much better. And if I download a new set of limb transformations or something, then I can automatically update that. I don't have to export the skeletons. So that would be ideal. But that's all for now. I hope you enjoyed this video. Thank you for watching and have a great day.